What is a p-value? The main goal of a statistical analysis is to estimate a parameter, often a regression coefficient, and to quantify the uncertainty in the estimated parameter value. The main way that we do this is to calculate a confidence interval. Usually, we report 95% confidence intervals. The 95% confidence interval provides a range of values in which we're 95% confident the true population value lies. The width depends on the standard error of the estimate. In addition, we may report a p-value. This quantifies the strength of evidence against the null hypothesis that the parameter value in the population is 0, which often corresponds to there being no difference between the groups being compared. For example, if we conduct a randomised trial comparing the effect of a new drug X with placebo on mortality, then our null hypothesis would be that there is no difference in mortality between individuals treated with drug X and those treated with placebo. P-values are often misinterpreted, and it's important to be clear what they tell us and what they don't tell us. The p-value is the probability that we would have observed an effect at least as big as the one observed if the null hypothesis is true. The smaller the p-value, the smaller the probability that we would have observed an effect at least as big as the one observed if the null hypothesis is true. So the smaller the p-value, the stronger the evidence against the null hypothesis. People often describe their results as statistically significant if the p-value is less than 0.05. However, we strongly discourage this. Using the term statistically significant often leads people to misinterpret their results. When you report the results of statistical analyses, you should report the estimate, the 95% confidence interval, and, optionally, the precise p-value. Here are 3 common errors in interpreting p-values. First, a large p-value does not mean that the null hypothesis is true, and should not be described as non-significant. This is because absence of evidence is not evidence of absence. You should always look at the confidence interval to understand the range of values that are compatible with the data. Second, p-values less than 0.05 do not necessarily imply that the null hypothesis is false. By definition, 1 in 20 comparisons in which the null hypothesis is true will result in a p-value that is less than 0.05. Third, do not assume that a result with p less than 0.05 implies an important difference. In large studies, even a small difference will result in small p-values. In summary, you should always report the estimates and 95% confidence interval. For the main study results, you can also report the p-value. Interpret the results based on all of these and never based on the p-value alone. This video was created for the MSc in Epidemiology and Public Health at the University of Bristol.